Okay, now we are onto our last rule, differentiating an exponential function. Now let's define exponential function. We will consider the natural exponential function f of x is equal to e raised to x, where e here is called the Euler number, which has the value of 2.718281 and so on. So e here is not any variable but a constant with 2.718281 as its value. So according to rule number 8, the derivative of an exponential function, if f of x is equal to e raised to x, then the derivative of that is e raised to x as well. Now there are so many rules, there's so many ways on how to get the exponential function which is available in the internet. But for this lesson, we will just be focused in this form of the exponential function where e raised to x and its corresponding derivative is e raised to x as well. Okay, for example number 1, we will differentiate f of x is equal to 3 e raised to x. So 3 raised e raised to x, so the constant here is 3 times the derivative of e raised to x, which is itself. So 3 times e raised to x. This is the final answer. Okay, for another example, it's quite complicated here. So the g of x, we will differentiate it equal to negative 4x squared e raised to x plus 5x e raised to x minus 10 e raised to x. Okay, so we have a constant here. However, we have two different separate functions here, the x squared and the e raised to x. So we will use the product rule for this one. Same goes here, we have a constant, but we have two separate functions, which is x and e raised to x. While here, it's a constant multiple that we could apply here. Okay, so let's start with the first one, negative 4, so it's a constant, negative 4, we will just separate that yet, and then x squared and e raised to x, we will use the product rule. So the x squared, or first function, times the derivative of the second function, plus the second function times the derivative of the first function, x squared. Next is this one, 5, we will separate that first, and then the x and the ex are treated separately. We will use the product rule for this one. So the first function is x, and then the derivative of the second function, e raised to x, plus the second function, e raised to x, times the derivative of the first function, which is x, minus the 10 times the derivative of e raised to x. Okay, so let's solve. So negative 4 here, and then x squared times the derivative of the e raised to x is e raised to x as well. So x squared times e raised to x plus e raised to x times the derivative of x squared is 2x. So e raised to x times 2x. Next is the constant, 5 times the x, and then the derivative of e raised to x, so x e raised to x, and then e raised to x times the derivative of x is 1, minus 10 as the derivative again of e raised to x, which is itself. So negative 4 times x squared e raised to x is negative 4x squared e raised to x. Then negative 4 times 2x, that's negative 8x times e raised to x. So negative 8x e raised to x. Plus 5 times x e raised to x is 5x e raised to x. 5 times 1 is 5 times e raised to x is 5 e raised to x, and negative 10 e raised to x. Okay, we will just combine like terms like this one, negative 8x e raised to x and 5x e raised to x, that's negative 3x e raised to x. And then 5 e raised to x minus 10 e raised to x is negative 5 e raised to x. So this is the answer. Negative 4x squared e raised to x minus 3x e raised to x minus 5 e raised to x. Okay, let's have a last example with a combination of a trigonometric function. So the h of x is equal to e raised to x times sine x minus 3 e raised to x times cosine x. We will differentiate it. Okay, so e raised to x and sine x is separated, so we will use the product rule. 3 is a constant, we will just separate that, and e raised to x and again cosine x, two different things, so we need to use the product rule to get the derivative of the function. Okay, let's start. So e raised to x and sine x. So e raised to x times the derivative of the second function sine x plus the second function sine x times the derivative of the first function dx e raised to x. Next is that's one. 3 e raised to x times cosine x. So it's negative 3 here, our constant, and then we will use the product rule. E raised to x is times the second function, dx cosine x, and then plus cosine x times the first function, dx times e raised to x. Okay, we will solve. E raised to x times sine x. Sine x is equal to cosine. The derivative of sine x is cosine x. So times cosine x plus sine x, and then the derivative of e raised to x is e raised to x again, minus 3, and then e raised to x times the derivative of cosine x is negative sine x plus cosine x times the derivative of e raised to x, which is e raised to x again. Okay, so e raised to x times cosine x is e raised to x cosine x plus the sine x times e raised to x is e raised to x sine x plus 3 times negative sine x is positive 3 sine x times e raised to x is 3 e raised to x times sine x. Negative 3 times cosine x is negative 3 cosine x times e raised to x is negative 3 e raised to x cosine x. Now we will combine like terms. So e raised to x cosine x, and then minus 3 e raised to x cosine x is 4 for e raised to x sine x. Sorry, this is cosine. So negative 2 e raised to x cosine x. And then e raised to x sine x plus 3 e raised to x sine x is 4 e raised to x sine x. So the answer, we can simplify that. This is the final answer, but we can simplify that here. E raised to x times the quantity of 4 sine x minus 2 cosine x. And that's all. I hope that you have learned something from this topic, and I hope that you are watching up to this point. Thank you for listening. God bless you. God bless you for your examination. Thank you and goodbye.